Okay, so we're going to talk about the concepts behind domain and zeros for functions. Um, the domain of a function, um, very basically, is going to be all values that x is allowed to be. Now, anything that it's allowed to be, based on what your function is. Um, now, there's really two ways that you can limit your function. So, limiting your domain. Because most of the time, um, you're going to have an infinite domain for a lot of functions. Now, there's two times that you'll mainly see this broken up. Number one, dividing by 0. So, how does that look? Well, think about this example here. You have 1, the function 1 over x. Well, remember, you're not allowed to divide by 0. So the fact that you have this x in your denominator, you're going to look at the whole denominator, whatever term is down there, and you're going to say, okay, well, based off of that, the whole denominator, x can't be 0. And that's the only domain restriction that you have. And you'll notice in this graph, and I'll just draw this real quick. This graph is going to look something like this, where it's not going to be allowed to be 0 at all. It actually diverges away, and we'll learn about why it does that later on. But this is one of those situations. You can't divide by 0, so if there is an x value, if anything in my denominator is 0, which is in this case is just x, then you will have a domain restriction. The second possibility is going to be an even root of a negative. Now, why did I say even root? Because really it's any even root, right? It doesn't have to be a square root. It could be a quartic root or something other than that. You don't run into those very often, but it's possible, right? So an example here would be, let's think of an even root. So like a square root of x. A lot of people might be like, well, it's a square root. Why not? Well, you can't take it of a negative number, or else you get an imaginary answer, and that's how we would restrict our domain. So in this case, anything that goes inside of a square root, the whole thing is not allowed to be negative. So you end up saying something like x has to be greater than 0. Okay, now why would I say x doesn't equal 0 versus x is greater than 0? Well, doesn't equal one number is very much easier to say than it's everything other than this. It means kind of the same idea. Greater than 0 makes things, greater than or equal to 0. Apologize. In this case, we can be 0, but we can't be below it. So we can be 0 or more, and so we would say x has to be greater than or equal to 0. So make sure that you understand these two concepts, and they go into every type of function that we're going to work with: rational functions, trigonometric functions, and so on. These are the two major types of domain restrictions. There are other ones, especially when you get to logarithmic functions and things, that certain things that you're not allowed to plug in. But these are the two main ideas that are going to mess stuff up. But we'll get to the logarithm stuff later. Now, zeros of functions, these are any values of x. Any values of x that allow my function to equal 0. Now, a 0 is not the same thing as an intercept. An intercept has to be real, whereas 0 could be imaginary or real. It could be both. It's just any value that creates a my function value equal to 0. So look at these two equations. So let's say we have x squared minus 1. Okay, we'll see that. So x squared minus 1 gives equals 0. Or excuse me, f of x equals x squared minus 1. And we'll have f of x equals, or we'll call it g of x. G of x equals x squared plus 1. So in this case, I'm going to get, if I set this equal to 0, so if I said x squared minus 1 was equal to 0, I would get x to equal positive or negative 1. Now on this side, if I set x squared plus 1 equal to 0, I'm going to get x to be positive or negative I. Now, over here, these are intercepts and zeros, because not only do they make my equation 0, but they are also real, and therefore they are intercepts. So they are physically seen on my graph. And so you can check them out right here. This is what this looks like. It's going to be, I have two actual places where this occurs. Now, on the other side, these are just zeros. And that's because for this graph, since it's being raised 1, there are actually no places where it intercepts. So even though that these are two answers, they're imaginary. But we do not call them intercepts. They are zeros. And zeros and intercepts share many of the same properties, except intercepts have to be real, and they have to intercept some line. So at least when we talk about those things, just make sure that those two things are different, but also very similar.